Hey, I'm Zeke,
And I'm Charlie.
and today we're going to be talking about semantic
Semantic search.
search. What is semantic search? Anyway,
I think the best way to explain a semantic search is a quick demo. So do you want to pull up Sticker Baker?
yeah, what is sticker baker?
Sticker Baker is a website I made that lets you make stickers with AI. So you type in a text prompt and then you get a sticker back of that prompt.
Amazing.
So this is a live feed of the stickers people are making. Do you want to click on one?
Yeah. All right, so we've got a flower in a pot here. What are all these other related images here?
So on the side, you can see similar-ish stickers, and these are all things that are semantically related to the sticker on the left.
So semantic search is happening under the hood here when I'm looking at
Yes,
a sticker. I'm seeing,
exactly.
yeah.
Every time you click a new sticker, so like try any of these, it's going to continue, it's going to regenerate the semantically similar stickers and put them on the right. Um, and you can also
Nice.
click search in the top right and search for something, and it
Nice.
will do that same semantic search. So that is a real life concrete demo of what semantic search actually is.
So how are you pulling this off? How does this work under the hood?
Yes, great question. Okay, can you see my screen?
Yep.
Okay, so this is all based on a technology called embeddings. And the idea of an embedding is turning the essence of an input into numbers. And for example, here is a sticker of a sunflower on the left. And when I embed that sticker, it turns into a long list or a vector of numbers, which we call the vector embedding. Over uh, or within this app, we can input lots of different types of stickers. Let's say a sunflower, an elephant, and this minion, and convert them into vector embeddings. Um, and the really cool thing about the embeddings is because it represents like the essence or the semantic meaning of the input, things that are closer together in meaning for humans will be closer together numerically. So for example, like a sunflower and a daffodil would be turned into numbers that are close in numerical space, but also meaning space for us humans.
Okay, so we
And
have like
that,
this array of numbers next to sunflower here 2.5, 6.3, 4.2.
yep,
And we can think of these as being parts of a coordinate in a multidimensional space. But instead of it being three dimensions, it's like some number of thousands of dimensions
1024.
that we can
Yeah,
hardly even comprehend. But the
yeah,
distance between embeddings in this space corresponds to how similar or different they are.
exactly. Yeah.
Amazing. So this is the model that you're using, right? ImageBind?
Yes, yes. So to get more specific, I'm using two technologies for this. I'm using ImageBind from Meta for creating the embeddings, and then I'm using a library called Hnsw, which is a math mathematical library for doing the vector search.
Okay, great.
Um, ImageBind is a really cool open source embedding model from Meta. I don't know why more people don't talk about it, but the thing that's cool to me about it is you can, well, there's two things. One, it's open source, and two is you can take embeddings from all these different domains. So you can make a text embedding and an audio embedding, etc., and it will all be in the same embedding space. So what that means in practice is that, like, let's say you embedded the audio of a train horn. That would be close in embedding space to the image of a train or to the text a train pulls into a busy station.
Amazing.
So
So in
that's
in
what image.
theory, in theory, your sticker baker site could allow me to record audio where I meow like a
Yeah,
cat and then images of a cat
exactly.
show up.
Yeah,
Amazing.
yes. And I don't have that yet, but I that's on the list, and
Okay.
I think that'll be.
Nice. Nice.
The second thing that's happening here is I'm using this library called Hnsw,
Yeah.
which uh, allows me to build the embedding index in memory. So this is the actual code that runs when the application starts up. And I don't need to go line by line, but the gist of this is it takes 30,000 recent stickers and adds the text embedding of those stickers to an index that is then loaded into memory so it can run really quickly. And then I can do a search on that index with every new search query using one line of code, a function called knn query, which is k nearest neighbors. And it finds the k, or in this case, 20 closest stickers in embedding space.
Got it. So if I understand you correctly, every time someone generates a sticker on the Sticker Baker website, you have some kind of background task that runs the ImageBind model to create an embedding of the image. You store it in the database, and then whenever the Sticker Baker website server starts up, it collects all of those embeddings and uses them to build a search index in memory.
Yep, exactly. You understood it
Amazing.
perfectly.
Cool.
Uh,
So this is like the kind of thing that we wouldn't have been able to build a year ago, and all of a sudden now, it's relatively simple web development type stuff to build a really fancy multimodal search. It's amazing.
yeah, and it's fast too. Like the embeddings run in under, or actually about a second, um, but often under a second.
Cool. Well, thanks for the demo. Sticker Baker is open source, so anybody who wants to dig in and see how this thing is built and start building something like it, go forth, explore, and learn about semantic search.
Sounds like
Thanks for watching. Bye-bye.